Hello everyone, today's topic is breeder reactor. So, a reactor that can produce useful power from a natural fuel such as uranium, and during the process of producing power it is capable of producing additional fissionable material equal to or exceeding the amount of fuel used is called as breeder reactor. So we have whenever we have a nuclear reactor we use some fuel. Now that fuel it produces power, but what if that fuel is capable of producing another fissionable material equal to how much whatever material we are using or more than that, then that kind of reactor it is called as breeder reactor. So what is the need for breeder reactor? We have uranium 235, and uranium 235 is the only fissile material which is available in nature. Plutonium 239 can be made from the fission of uranium 235 in a reactor containing uranium 238, but this process is involved and expensive. So when we have studied the four factor formula, that time we have seen that when fast neutrons are emitted from uranium 235, some of the neutrons they may interact with uranium 238 to cause the fission of uranium 238. But and then from uranium 238 you can also get plutonium 239, but this process is very expensive. Similarly, uranium 233, which does not occur in nature, it can be made in a reactor containing thorium 232. So we have this facility of making some kind of fissionable material from the fuel itself. The problem of availability and cost of nuclear fuels is a serious one, and this problem can be solved by considering the fact that on an average more than 2 neutrons are emitted per fission. So what we can do, suppose we consider the chain reaction of nuclear fission of uranium 235. We know that uranium 235 it interacts with a neutron, it produces compound nucleus uranium 236. So what is happening basically during the fission of uranium 235, we are getting a compound nucleus uranium 236 which undergoes fission into barium and krypton, suppose, and along with that 3 neutrons are emitted. Now one of these neutron, suppose 3 neutrons are emitted, one of these neutrons it has to again combine with another uranium 235 atom so as to cause the fission. Then only that chain reaction of uranium 235 it will go on, right? So जो भी 3 न्यूट्रॉन्स है उसमें से एक न्यूट्रॉन हम लोगों को चाहिए चेन रिएक्शन कंटिन्यू करने के लिए. Now what about the other 2 neutrons? Suppose other 2 neutrons which are left, those neutrons we are using to convert an atom of uranium to one atom of plutonium, leaving 1 neutron. Like suppose this neutron I'm using, it is captured by uranium 238, it is producing uranium 239 that undergoes beta decay, it produces neptunium 239 which undergoes beta decay again and produces plutonium 239. So if the एक न्यूट्रॉन हम लोगों ने यूज किया फॉर कंटिन्यूइंग द चेन रिएक्शन ऑफ यूरेनियम 235, second neutron we have used for to produce plutonium 239. Now we have third neutron also. If that last neutron could also be used to produce another atom of plutonium, then from what is happening, from one atom of uranium 235 I'm getting 2 atoms of plutonium 239, and plutonium 239 it is fissionable material. So in other words, more fissionable material would be produced than consumed. हमने consume कितना किया, एक ही uranium 235 consume किया, but what we got 3 neutrons out of which उसमें से एक neutron it is used for continuing chain reaction, and other 2 neutrons they are producing plutonium 239 which is fissionable material. So एक uranium 235 से हमें 2 plutonium 239 मिल रहा है which is fissionable. So there is a possibility that some neutrons may get lost by leakage or absorption by some other material, but so long as more than 2 neutrons are produced in a fission, there is a possibility that more nuclear fuel may be produced than is consumed. So if we are able to produce fuel more than what we are consuming, then that process, it is called as breeding. Now, this terminologies we are using, so you should be aware of this. What are fissile and what are fertile materials? So the process of breeding fissionable material depends on 2 materials, one of which is fissionable and one of which is fertile. So when we consider uranium-238 and plutonium-239, thorium-232 and uranium-233, they form such pairs. Like consider the pair of uranium-238 and plutonium-239. Suppose that enough plutonium-239 is available to achieve a chain reaction as in a system which can be used to produce power. The thermal fission of plutonium-239 yields 3 neutrons. From uranium-235, one atom of uranium-235, suppose I get 2 atoms of plutonium-239, and this plutonium-239, it is fissionable. So from one plutonium-239, I am getting again 3 neutrons. So that if some of these neutrons could be absorbed in uranium-238 to form plutonium-239. So in this case, what is happening? Uranium-238 is the fertile material. What is fertile material? A material which is able to produce fissionable material. From uranium-238 हम लोगों को मिल रहा है plutonium-239 which is fissionable. So uranium-238 हो गया fertile material. So uranium-230 is the fertile material, and although it is not itself fissionable, uranium-238, it is not itself fissionable, but it can be converted into plutonium-239, which is a good fissionable material. So in this reactor, more plutonium-239 is produced than is consumed. So the nuclear property that determines whether the property of breeding exists is not the value of number of neutrons emitted per fission, but the number produced per neutron absorbed in the fuel. So generally for thermal reactor, eta neutron absorbed in the fuel, it has a value 2.1 and 1.94 for uranium-238 and plutonium-239 respectively. In India, reactor research center at Kalpakam is devoted to this task. So this is RRC Kalpakam, so which is a breeder reactor. So it is also called as Akshay Patra. So this novel nuclear reactor is a kind of an Akshay Patra, the mythical goblet with a never-ending supply of food. So in epics, it is mentioned that there is some Akshay Patra where if you keep the food, that it is a never-ending supply of food. So there will always be food in that particular bowl. So that is Akshay Patra. So this fast breeder reactor, it is kind of Akshay Patra because these are a special kind of nuclear reactors that generate more atomic fuel than they consume as they work. So why it is called as a fast breeder reactor? Fast breeder reactors are called such not because they run faster, but because the neutrons that sustain the atomic chain reaction travel at a much higher velocity than neutrons that run the traditional atomic plants. So fast, it is word not for the running of the breeder reactor. It is used for the neutron velocity. Neutrons are having more velocity. So that is all about breeder reactor. Thank you so much.